Hello, this is Holly Larson, and welcome to my Assessment 4 for Computer Science 105, where I'm going to be talking about everything that we've learned so far in computer science. So one of the first things that we discussed was basic Outlook email settings. So if I go to houndmail.loyola.edu, it will bring me to my Outlook email that's set up through Loyola. And I can click here to create a new message. And here I would type in who I'm sending it to. CC stands for carbon copy. It's to send something to someone who you want the email to go to, but they're of less importance to the person than you're originally sending it to. There's also BCC, which stands for blind carbon copy, where you can send someone something without them knowing who else the email was sent to. There's encrypt, where you can encrypt the message, which is similar to the protect that we talked about in the modules. You can attach files over here. You can forward emails, reply to emails. If I go into this email, I could reply that way, forward it, and such like that. So that's pretty much Outlook. Oh, and for signatures, you can go to this gear here and type in signature and edit your email signature. A lot of people just put their name, their major, their school, their year. I just have my school and my year because I'm not sure about my major yet. And then also a lot of people automatically include that in certain things. So that's pretty much the basic email settings that we talked about. After that, we talked about Outlook Calendar. So if I were to go back to my email and then click here, it would bring me to my Outlook calendar where you can create events. Like clicking new event here, I can create an event. You can put a place for an event, you can invite people to an event and they can RSVP or not RSVP, or even when you invite someone to an event, you can see if they already have an event during that time in their Outlook calendar, which is a really handy feature. You can set reminders, so you can get emails to remind you about events in your Outlook, which is also a really good feature of Outlook Calendar. And you can also have repeating events like your classes, like I have here. That little symbol there shows that that's repeating. So that's a really good feature of the Outlook Calendar. And then we also talked about sharing documents, so you can screen capture. You snip on a Windows computer, but on a Mac you do Command-Shift-4, and it would show up like this, and I would slide and drag like that. And over here in the corner of my screen is now that screenshot, which will show up on my desktop, and I can use it from there. You can also share something by share document by going to the document, clicking share. You can get a shareable link. It's just important to specify whether or not that person can edit the document or not. You can go into here and change how that sort of works for you. So yeah, different ways to share documents that way. So before Windows was the disk operating system. I can't exactly show that right now on this computer because I'm on a Mac. But, and I also talked about file extensions a little bit in this slide, different file extensions, just so the type of file it is. That's this table shows that. But Unix is the operating system underneath the Mac operating system. So if I go to this little magnifying glass here and I type in terminal and I launch it, which was already launched, this shows up, and I can use these different commands here to do different things. For example, if I type in ls, it means list files. It's going to list the files that are just broadly in there. And another feature that's similar to that is the Finder. I can go into my Finder, and these are just my disorganized files, and I can control-click, and I can do different things through that. So that's the Finder. So Outlook Cloud File Storage is really useful for Loyola. You can make folders and organize all of your Excel spreadsheets and your PowerPoints and your Word documents through there. You can go to create new here, create new folder, assessment 4, I don't know, and create a folder. You can share a folder with someone pretty easily and such like that, so that's great. And so hardware and software. Hardware is a physical aspect of a computer, whereas software is sort of the non-tangible parts of the computer, like the operating system and other parts of the computer. So a Chromebook is kind of considered like an inexpensive computer. The data is stored in the cloud, whereas Macs, the software and the hardware are made by Apple and such, and any manufacturer can make a Windows computer. And Windows has Windows 10 software that you can use on that. And Java is a programming language that can be used to make operating systems and software and such like that. So we also talked about the von Neumann model. This is it here as it's shown. Inputs flow data into the computer that goes through the CPU in order to get to the RAM, which is the random access memory, which I'll talk about soon, and then the computer can flow data out into the output, and so the arrows here are showing data flow. So that's how data is flowing in and out of the CPU to the operating system and storage. And just the most important takeaway of this model would be that data has to go through the CPU to get to RAM. So, okay. Almost sneezed. Okay. So inputs for a computer could be a mouse, a microphone, a webcam, a touchscreen. Like I said before, they flow data into the computer, and then data flows out of the computer through outputs such as speakers, monitors, printers, and such like that. Operating systems just contain pretty much the instructions for the computer. There's a ton of different kinds of operating systems like Linux and Mac OS and Windows. For example, my phone is an iPhone. It uses an iOS operating system. And a CPU is a central processing unit. Is a little different than the operating system. Like I said before, data has to flow through the CPU to get into the RAM. There's different speeds for the CPUs. I showed in this slide over here. For example, 3 gigahertz is 3 billion instructions per second. So that's a lot for computers these days. Their CPUs are very powerful. Sometimes if you're searching for computers online, you can see the i3 or i5 or i7 CPU. i7 would be the strongest and best of those. So RAM and hard drive. Hard drive is long-term storage in a computer that has this disk here. This is what it looks like. And RAM is random access memory, so it turns off every time you get rid of the computer. So, for example, my computer may have only 8 gigabytes of RAM, but it may have 200 gigabytes of hard drive, possibly. So the RAM's usually less than how much the long-term data storage could be. So now I'm going to talk about bits and bytes and all of that. So bits are a binary unit of communication that uses base 2, which means that they use the digits 0 and 1. And hexadecimal uses base 16. There's also base 10, which is sort of our interpretation of numbers. So what is important to remember is that base 16 uses the digits 0 to 15, base 11 uses the digits 0 to 10, base 12 uses the digits 0 to 11. So let's say someone were to have 3 in base 2, that doesn't exist because base 2 only uses the digits 0 and 1. And a byte is 8 bits or 2 nibbles, so yeah, that's that. And you can also, I'm going to show you how to convert in between these units of communication, but Excel also has functions that do that also. So base 10, as I mentioned before, is our interpretation of numbers using the digits 0 through 9. So pretty much what base 10 means, let's say we were to look at the number 174, it means 1 100s, 7 10s, and 4 1s. So, and that is shown by, so since it's base 10, there's 10s here, and then 10 to the 0 is 1, so it's 4 1s, 10 to the first power is 7, so it's 7 10s, and 10 squared is 100, so it's 1 100. So this is just pretty much the breakdown of what base 10 means. So the column weight chart is something that we use to convert in between these different bases. So I'm just going to go into an Excel spreadsheet to explain that. So I'm just going to go through a problem in order to explain it. So let's say I were to try to convert 14 base 10 to base 2. First I would make a table like this. I would have a power row, a power value row, and then the converted value row is what I'm going to calculate. So the power row, I would just take whatever the base is, so it's 2 in this situation, so 2, or here it's 16, so I'd go to 16. And just for each row, I would raise it to an extra power, so to the 0, to the 1, to the 2, to the 3, to the 4, and then I just put the values there so that I can better go through the problem faster. So let's say I was trying to convert 14. So first, I would look to my leftmost column, and I would look at 16, and I would think, how many times does 16 go into 14? It doesn't go in at all, so I'm just going to cross it out or highlight it black for our purposes. So now I'm looking at 8, and I'm going to think, how many times does 8 go into 14? It goes in once, so I'm going to put a 1 below that 8, and then I'm going to subtract 8 from 14 since I just used 1 8. So I'm going to say equals 14 minus 8, which is 6. So now I'm going to look at 4, and I'm going to say, how many times does 4 go into 6? And 4 goes into 6 once, so I'm going to put another 1 here, and then subtract 6 minus, equals 6 minus 4. So I have 2 left, so now I'm looking at 2. How many times does 2 go into 2? Once, so I'm going to put a 1 there. I'm going to subtract 2 from 2, equals 2 minus 2. And I'm left with 0, so 1 goes into 0 0 times. I'm going to put a 0 there. So the equivalent of 14 in base 10 and base 2 is 1 1 1 0. So similarly, if I'm trying to convert 344 base 10 to base 16, I would make a table with the power row, the power value row, very similarly as I did before, and I would look at 344 and I would say, how many times does 344 go into 4096? It does not go in at all, so I'm going to cross it out and highlight it black for our purposes. Now I'm going to look at 256, and I'm going to say, how many times does 256 go into 344? 1 time, so now I'm going to subtract 256 from 344 equals 344 minus 256. I'm left with 88, so how many times does 16 go into 88? I don't know that off of the top of my head, so I'm just going to do a calculation here. Equals 88 minus 16. So it goes in 5 times, so I'm going to put a 5 here. 16 times 5 is 80, so I'm going to subtract 80 from 88 equals 88 minus 80, which is 8. So now I'm going to say, how many times does 1 go into 8? And that's 8 times. So I'm going to put an 8 here, and then so 344 base 10 equals 158 base 16. If one of these values were to turn out to be 10 or higher, I would use letters to show those numbers. So for example, 10 would be A, 11 would be B, and so on. So last I'm going to convert 11101 base 2 to base 10. This is sort of going the other direction as I've been explaining. So what I would do in this situation is I'm just going to put the 1101 into this table this way, 1, 1, and then to figure out the base 10, I'm just going to multiply these and add them up. So I'm going to add 8 plus equals 8 plus 4 plus 1, 13. So 11101 base 2 is 13 in base 10. So that's how you would convert those numbers. These are just explanations that I put in the PowerPoint before I decided that I would explain how to go through the problem in Excel, but this just shows this in other ways with other examples and some color coding, just explaining before here. I used a problem with the A, which is a 10 in hexadecimal, and yeah, so these are just pretty much what I explained. Notepad is something we went over in Module 4 that pretty much we used to just show the, to talk about measurements of data. So Notepad is something where you can just record data and not have it, and it will just save the text so you can see the size of that text. So this is just a summary of measurements of data to better understand those. A kilobyte is about a 5-page paper. And yeah, that's pretty much it. So thank you for watching. Bye.